Let us, for example, we say like this is the equation of the signal. Now we do not have any idea that whether this system is linear or it is time variant or invariant, or it is like yeah, is unstable, stable, or what is the nature of the causality of the signal. So for checking these things, let us consider like another equation as zt is equal to x of t minus t naught for checking the time variancy, like at what instance that if the value at particular time instance t is equals to 1, this particular signal value was there, and at t is equals to t naught, like another instance some other value was there. If the signal at those 2 points will be different, then we'll automatically say the nature, what is the nature of the signal. That is the nature of the signal is time variant if the values becomes different, come out to be different. Like now y dash t will come out to be, like we will put t minus t naught in this equation, so 2x t minus t naught plus 3 will be there. So y t minus t naught is equals to 2x t minus t naught plus 3. So we can see that this y t minus t naught equals to the value, this particular value. Okay, so both the equations are somewhat similar, so we can we can infer that the system is time invariant. Now, okay, like we consider another set of signal equation, like which in which we should make sure always that whenever the non-linear functions such as log, sine, or any trigonometric functions is added in the equation, then it will be non-linear always. So like it will be non-linear always. We do not have any other option when we are asked to comment upon the linearity, whether the system is linear or non-linear. We'll just say that the system is non-linear. So now zt is equals to x t minus t naught. So y dash t will be ln of x t minus t naught, replacing the this value with t minus t naught. So now yt. So we can like nature or linearity is all is understood that it is non-linear. Now for when we come out to the next question, like yt is equals to xt minus 2, whenever the interval is given or the finite value is being defined, we can always see that if we talk about the stability, what do you mean by stable? Like whatever the, if the value come out to be finite, then it will be stable, otherwise it is unstable. So you can see that the time interval lasts between the finite interval, not up to infinity, sorry. So it will be it will not be infinite, that is it will not be unstable, it will be a stable system. So likewise for t greater than equals to 5, t plus 1 is this greater than equals to 5. Now this particular, this half of the signal will be under the range of unstable. So we can say for linearity, first of all we'll check xt. When xt input will be applied to the system, we get the output yt. So xt, when xt will replace to xt minus 2. So whenever this type of interval is given, we need to write it on the form of the unit step signal, so that it will be more easy for us to calculate. So xt minus 2, okay, what is this? Taking on the first half of the equation, first half of the signal, when the signal lies between minus 2 to plus 4. So xt minus 2, so what will be minus 2? At t is equals to plus 2, the signal will be u of t plus 2. So u of t plus 2, and t is less than equal to 4 means the final value will be 4. So t minus 4 is equals to 0, that is the finite value will come. Okay, so ut minus 4, why? You must be thinking that ut plus 4, why is it not like that? Because ut plus 4 will give us, u means t plus 4 equals to 0. If we say that, then t is equals to minus 4. We don't need value of value less than minus 2 in this. According to this equation, we do not need the value less than minus 2. So we need the value in this range only. So that is why we have put ut minus 4. So ut plus 4 minus ut minus 4, what the signal will look like, I'll show you. Okay, so like this. So ut plus 2 will be like t is equal to 0 this one, so t is equals to 2 at this particular instant, and t is equals to 4 at this particular instant. So ut plus 2 will be t plus 2. Okay, so t plus 2 means the value which is which lies less than minus 2 to infinity, first of all, like this. Ut minus 2, this. Okay, and then ut minus 4 will be plus 4, like this. T less than 4, this one, from minus infinity to 4, and from minus 2 to 0. So which value, common value we have got? Ut plus 4 minus whole this. Why is it like that? Because which signal is greater? The signal from minus infinity to 2 is greater than the signal minus infinity to 4. That is why we have got this value. So the system x t plus 1 equals to 0. The system is linear. Now commenting on the, so I will tell you how this equation will be there. So ut plus 2 will get a finite value, that is a delta function, single, without taking any difference between those two. And then ut minus 2 is another delta signal, you can say. Okay, so 1 minus 1 will be 0. Okay, so this whole we'll get as 0. So now taking the rest half of the signal, that is xt minus xt plus 1, whose time interval value is greater than 5. So xt plus 1, likewise ut minus 5, because at t is equals to 5 we need to find out the value, that is positive value we need to find out. So t is equals to 5, not t less than 5. Why positive value? Because you can see that t is greater than equal to 5, the condition is already given, so why will you take out the small value? So at t is equals to t naught, for checking the this linearity is confirmed. The system is linear because you can see why the system is linear. Now I've already told you. Now t is equals to t naught, t minus t naught for time variance is at t is equals to x minus xt minus t naught. Why directly? So x of t minus t naught, when we'll put t minus t naught in this equation, so xt minus t naught minus 2, the first half of the equation I'm talking about, ut minus 2, this one, minus ut minus 4, plus to get the negative value here. Okay, so plus the second half of the equation, xt plus 1, xt minus t naught plus 1, ut minus 5. Okay, the second half of the equation. So we can check the value that at t minus t naught we are getting somewhat this value is different than this value. So it is time variant.